Welcome to qnawire.
Hi, so over here we need to use curve arrows to show the electron movement of the reactant side to draw the products for this compound over here. Recall that over here the amide is actually a compound that has an extra pair of electrons that is going to take away this hydrogen atom and it is going to produce a carbonion, which is stabilized of course by sodium plus the corresponding NH3. So first of all, the acid in this case is going to be the alkene, the base is going to be the sodium amide, the conjugate base is going to be this compound over here, and the conjugate acid is going to be NH3. So in order to know what is going to be the favored direction, what we need to assess is where is the weakest acid. So in the case of the alkene, the normal values for the pKs for alkenes are of around 45, while the corresponding pKa for the NH2-NH3 pair is going to be of around 35. So the one that is the weakest acid is going to be the alkene. That means that our reaction is going to be favored towards the reactants. The actual reaction looks like this. So taking advantage of this, let's skip all the way directly to this problem over here. What we know is that the pKa for the hydrogen of a terminal alkyne is going to be of around 25. So what we need to use in order to deprotonate only the terminal alkyne is going to be either using sodium amide, which we already said that the value for the pKa corresponds to around 35 of the conjugate acid, or another option is going to be LDA, which is also going to have a pKa of approximately 36. Now remember that LDA is going to be lithium, the isopropyl amide. So now with this, what we can do is finally go with this guy over here. Let's roll the pair of electrons as required. And over here, our oxygen is going to have two pair of electrons. What happens here is that the electrophile, which every Lewis acid is going to be an electrophile, is going to be the BF3, and the nucleophile is going to be the ketone over here. So what is going to occur here, just to make things a little bit more clear, is going to be the attack of the lone pair of the oxygen towards the boron atom, which is going to produce the following compound. The oxygen is going to be positively charged, and we're going to have BF3. I'm going to abbreviate it directly as BF3, and the boron now has a negative charge. Recall that this is going to happen because the sigma orbital of BF3 is going to be empty because we have empty 2p orbitals on boron. And with that, it would be all. Thank you very much and have a good one.